solution. So there's actually two solutions for this, and the first solution is pretty unique. So it's going to be sequences. So sequences is something, a pattern, a reoccurring pattern that we see in the figure. So clearly the first ring given in the problem says that there's 8 unit squares. So this is the number unit squares, and this is the figure. This is the figure number. Figure number. Okay. So figure number and unit squares. So it's so for the first one, the first figure, it has 8 unit squares. For the second figure, it has 16 unit squares. And to double check, we can continue this pattern and find in the third figure there's 1, 2, 3, 4, 5, 6, and we just count all of them, and it is 24. 24. So we can see that the simple pattern is just adding 8 every single figure, and for each increasing figure. So we're just adding 8 unit squares, and that makes our lives much simpler because we can simplify this. And since it's asking for the 100th ring, there has to be 99 differences, or 99 adding differences. For example, between the first and second figure, 8 and 16, the difference is 8. And clearly, since there's two figures, there's only one difference. And if there's 3 figures, there'd be 2 differences. So if there's 2 figures, it's just number of figures minus 1. That's how many differences there are, equals differences. So for this one, there's 99 differences, and each difference is 8. So times 99, and that is equal to 100 times 8, which is 800 minus 8. So that is 792. And we're just adding that to the first number, because again, that's how we find the 100th ring, just by adding 99 differences and to the first number to get the 100th ring. So that's easily 792 plus 8, which is 800. So that's the first solution, just finding arithmetic adding sequence, and we just see the pattern, and it's pretty easy to find it out. Another way I solved it is by using the same method. However, we just simplify it. 8, 16, 24, we keep on going, and we just take out the 8, and then it's just 1 plus 2 all the way to 100, because that's 100 figures starting with 1, and we can just multiply it back in, which is 800. And that's easy 3-minute 3-minute think and solve problem. And the other way, the second solution, second actual solution, is solution number 2 is solving it without sequences or manually, and using variables. So if we use variables here, the first figure looks like this, and the shaded square isn't included in the first figure. So we can rewrite this as n being the figure number, and in this case it's 1. So we can basically divide this figure into two different rectangles, and there's 2 of each rectangle. So we have times 2 and times 2. This 1 by 3 is just the ones on the left and right. This 1 by 1 is on the ones is the one on the bottom and top. So that is equal to 8. So we can rewrite these rectangles as 2n, the first rectangle 1 by 3 as 2n plus 1, because the figure number is 1, and then times 2, we can just add 1. And we can rewrite the second s- second one second rectangle 1 by 1, or square, whatever you like to call it, as 2n minus 1. And that works too, because we just multiply, we just have 1 times 2, which is 2, and then minus 1. However, since we have 2 of each, we just multiply by 2, and then we just add. So we get 4n plus 1 and plus 4n minus 1. And that's 8n. That's just 8n. So that is the number of squares in each figure for each figure. And we just plug 100 in because we're looking for the 100th figure, the number of unit squares for the 100th ring. And that's easy. We just get 8 times 100, which is just 800. So that's using variables to solve for the unit squares, the number of unit squares. And me personally, I saw the first solution earlier and it was pretty easy to solve, but sometimes sequences aren't usually the best solution, so I just putting this solution out there for those who want to learn it. So if there's any problems or concepts you want me to go over, please leave them in the comments down below. Otherwise,